Hello, my name is Daniel Gomez Valdez, and I am here to showcase the drone that I have designed as part of a swarm of drones that would help in the event of a disaster. I would like to point out that in the past couple of years, natural disasters are becoming more vicious and create a heavier levels of casualty around the world. I aim to minimize the time emergency personnel can arrive at the site of the disaster. Clearing roads to get to a certain location can be delayed for hours, as well as reducing the fatigue for search and rescue personnel that have to carry a heavy load of equipment with the addition of their PPE. Um, Short and to the point, the requirements for the drone um, are pretty simple. The robot proposed here is an aerial portable carrying drone that would be able to carry a heavy load of items needed that would be hard for a vehicle to pass through or a helicopter to land on. This drone would be able to fly, hover, and safely land in a small area that can assist medical or emergency personnel. So, the following are the requirements to maximize the possibility of this drone to be effective. The drone would have to be small enough that can replace the arrivals of helicopters in disasters where people are already there assisting the wounded. The drone would have to be affordable as it would be utilized as an auxiliary support, and many departments would see the benefit of investing in it. It would have to carry a minimum of 50 pounds of equipment that is necessary but can cause great fatigue for search and rescue personnel. Be able to be airborne for a long period of time, as search and rescue can be time consuming, and to deliver equipment, it must be able to do several runs back and forth. Um, so here is one of the basic designs for the aerial drone. This robot would be strictly aerial drone. Um, Again, with the capability of lifting or carrying up to 50 pounds. This robot would also have the capabilities of landing if necessary, but it would be constricted to being stationary where it landed. The design is basic but essential, as it would have propellers to be airborne, would have a flight light indicator or activated light in order to have the drone be visible. Several distance sensors or proximity sensors to be able to land safely, deliver equipment, and be aware of its surroundings. It would also have clamping mechanisms, as you see here with the lines, and it would have a landing mechanism here annotated with the little legs. Here's more pictures of the drone and its basic lengths. The drone would be about 4 foot high. It would be about 6 foot in length, and it would be about 5 feet wide. The design for this drone is simple, but yet efficient. It needs to be able to do not only the cargo equipment lifting, but it would also be nimble enough to be in the air for several hours and be consuming a minimal amount of energy. The simple design can be made with aluminum alloys to make it lightweight and cheap to make. The landing mechanisms are simplistic to be able to just land or be stowed away. The pulley system is integrated on the front and in the back of the drone to be able to have this line to drop down or pull it back up. The drone system can carry several things. It has 4 lines in order to stabilize the drone as it's carrying its equipment, as seen here. It can carry crates, boxes, backpacks, any sort of item that would be required to be picked up or loaded or delivered can be assisted by this drone. Moving on. So here's the basic circuitry design for the drone. Here's a basic format. As stated, I have the following sensors. There will be a proximity sensor here as the bottom sensor, the forward sensor to know its surrounding. It would have a manual bypass in order for the medical personnel to come in and if there is a problem with signaling or if there's any sort of other types of things that are needed by the medical personnel, they can access it through this manual bypass. I have a couple motors here to simulate the landing and the clamping mechanism, and we have the pulley system for both the back and the front. Moving on, here is the coding associated with this drone. The following circuitry here is the list for the process in which the drone should behave. We have a code for a constant flashing of the light to have a visual representation that the robot is active. We also have coding for the pulley systems in which the motors will move clockwise or counterclockwise in order to simulate the lines dropping or pulling back into the robot. We also have the coding for the clamping and landing mechanisms in order for the robot to safely land and activate the landing system or clamp down into the equipment or unclamp to simulate unloading and loading into the chamber. And lastly, we have a code for manual bypass in which the button can be pressed and then the robot would behave accordingly. Demonstration for my cargo drone. Here's the circuitry that has been set up for it. It's just the basic proximity sensors from the forward and the bottom sensor. The forward will be utilized as a proximity or surrounding sensors, and the bottom will be a proximity from the ground in order for it to land or to know it's airborne. We got two servo sensors here acting as a clamping mechanism and to actuate a landing legs in order for it to safely land and not land on its belly. We also have some motors here that will go forward or back to simulate lines being dropped in order to be delivering equipment or lines being picked up back into the drone and to be taken away back into its central hub. I also have here a LED that continuously flashes on and off just to give a visual representation that the drone is active and ready to receive commands. So if we start the code or the simulation here, you see that we go straight into a clamping mechanism. The legs are unhooked or the legs are tucked away because the drone is readily flying or actively flying. So we got the code here to simulate a drop off. It needs to read a certain amount of distances because that's the reason why we got the drone. It needs to be close enough to the person and its surrounding in order to know that the equipment will be delivered within proximity of a person, and it needs to be high enough in order to have a safe line drop to the position that it's been indicated. I have a manual button bypass here and just for personal preferences, or if it doesn't read the command center readily available, the person there should be able to manually bypass it. So to unload, I have here that the distances need to be read within 60 inches for the forward or proximity surrounding distances, and it needs to be higher than 96 inches from the ground in order to do a safe delivery. So let's say the central command sends out a code to deliver. It will read the distances, and as you can see, nothing happened because we're too close to the ground to make a safe drop. So if we go ahead and increase our distance from the ground, which is above 96 inches, we send out the command again. You'll see here that the motors actuate because we're close enough to the person in front of us and we're far away from the ground. Same goes for the button here. If we press it, it read it, and the motors actuate. We also see here that the LED is just continuously flashing, telling us that the robot is ready to go. To unload or to load back up, to take the equipment away or to take the equipment to the people, we send a command to load it up to its belly, and you see here that the motors are rotating in reverse to simulate it loading into its belly. Here in the landing mechanism, we got that the distance sensor needs to be close enough to the ground in order for them to actuate. So if we decrease the distance here and we just keep decreasing it, we're getting close to the ground. We see here 36 inches should be, or about 3 feet should be when the legs should come out to be ready to make a landing. And so again, we're going back up, we're flying up, and once we hit 36 inches, you'll see that the legs get tucked back in. Here for the clamping mechanism, we got right now it's in that clamping motion. It is flying. We hit everything's ready to go. It's over 96 inches. It unloads. Right, correct. The motors go, and we're ready to unclamp. We send out a code, and the clamping happens. And then back again, everything's ready to go. All the equipment needs to return. We send out a clamping mechanism, and it'll clamp it up, and the drone will fly away. Thank you very much for seeing my demonstration. I hope this was a good one. Goodbye.